Let's talk chemistry with Pastor Dan. We're looking today at bonds, chemical bonds. Da 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 da. A little corny, a little cheesy, I know, but hey, hopefully got you a laugh. All right, bonding is defined as a process of combining two more elements chemically. Now, there are primarily two ways that we're going to look at bonding. A few others we'll look at real briefly at the end. First is called ionic bonding. Ionic bonding is defined as bonding due to charge caused by electron transfer resulting from ionization energy and electron affinity. Now remember we talked about last section, ionization is the energy needed to lose one electron. Electron affinity is needed to gain electrons. So which one wants to lose? Those are metals. And which one wants to gain? Those are non-metals. So an ionic bond is a metal to non-metal bond. All right, so in order to do this, we need a concept of an ion. An ion is a charged particle, or ions are charged particles. There are two types of charged particles. We either have a cation, which is a positively charged particle, or the other one, no, it's not a dog ion. The second one is called an anion, which is a negative. How do you keep those separate in your mind? Well, I'll try to keep it as, I'm a simple man, trying to make something that works for me. So in cation, there's a plus right there. So you see the plus, that's cat, that's positive. All right, and anion, negative, there's an N there. So that's how you keep those straight, know which one's which. All right, so let's start with a process of bonding, NaCl, table salt. We know that's an ionic bond, that's a metal to non-metal. So if we look at the periodic chart, sodium has 11 protons. If it has 11 protons, it also has 11 electrons, 2 in the first energy level, 8 in the second, and 1 electron in this outer level, only 1 valence electron, if we remember back to our chart. All right, chlorine, on the other, has 17 protons, so 17 electrons, 2 in the first, 8 in the second, and then 7 in the outside. Now, an atom is most stable if it has 8 in the outer shell. So this one out there, sodium doesn't like it. It really wants to get rid of it. So that's what it does. It kicks it out. Now, when it kicks it out, what happens is now we have 11 protons and 10 electrons. So the charge there becomes positive. Well, this one just hang out there. So it's going to slowly migrate over to the chlorine where they have 7. It wants to get to 8. So it really wants that 1 electron badly. It grabs it. When it does, it becomes negative. Those are opposite charges, equal in magnitude. In other words, you add them together, you get 0, and we get NaCl. Now, this process, we can show this. It's called Lewis dot. When we do Lewis dot, we do the same process again. So we start with the number of valence electrons we start with in the natural atom. So sodium has 1. Chlorine has 1, 2, 3, 4, 5, 6, 7. Okay, we go around. We don't go next to each other. Is it easier to lose 1 or gain 7 for sodium? Well, obviously, it's easier to lose 1. So I have no dots. When I have no dots, it's charged. We use a bracket to show that's charged. Because I lost an electron, it's positive. Now, chlorine, is easier to lose 7 or gain 1. Well, hopefully you see that'd be easier to gain 1. So we put 8 dots around it. Brackets, because it's charged now. Charge is negative. Now, those are opposite charges, equal magnitude. We add them together, you get 0. Form is NaCl. Let's try another one. Let's try Ca and Br. So how many valence electrons does calcium have? 1, 2 from the periodic chart. Chlorine has 1, 2, 3, 4, 5, 6, 7. Easier to lose 2 or gain 6. Easier to lose 2. Brackets, no electrons because we lost them. Brackets because it's charged. Because you lose 2, it's plus 2. Chlorine, easier to lose 7, gain 1. Easier to gain 1. So you put 8 dots around it. Brackets because it's charged. And it's negative. Now, those are opposite in charge, but they're not equal magnitude. So how are we going to make it equal magnitude? We're going to grab another bromine. You go, wait a minute, where did that come from? Well, in reality, we never have an individual atom. Even if I have like 0.0005 grams, a very, very small amount of it, I have billions of atoms there. So they're there. You just have to trust me. They're there. Does that equal 0? It does. So the formula then is CaBr. We'll put a little subscript 2 down here to represent how many there are. All right, let's try this one. All right, so we have 3, we have 6. Okay, so we're going to end up with a plus 3 and a minus 2 with the brackets. Now those don't equal 0, so I'm going to add another chlorine. Now we have plus 3 and minus 4. doesn't equal 0, add another aluminum. So it's plus 6 minus 4. So another sulfur. Now we got plus 6 minus 6. That's equal magnitude, opposite in charge. Formula is Al2S3. All right. Pause this. Try this one on your own. See what you come up with. All right. So do the process. Ready? Pause it. Start it. Here we go. And that's our answer. Now, there's another way we can also do this. It's called oxidation. It's quicker, and it's associated elements for ionic bonding. We're going to use our periodic chart. So get your periodic charts out again. And there's our periodic chart. And we remember valence electrons, we have 1, 2, 3, 4, 5, 6, 7. We're not going to work the transitionals, and we're not going to work the rare areas. Now, if I have, we're only going to look at a couple of these. We're going to look at the alkalis, the alkalines, nitrogen group, oxygen group, and halogens. Okay, so if I've got one valence electron, it's easy to lose one. So the charge there, all of those have an oxidation number, a number for bonding, a +1. They have alkalines have 2. Since they have 2, it's easy to lose those 2. All of them have a +2. Now, nitrogen group down. Nitrogen group down has 5. So it's easier to gain 3. So if I gain 3, the oxidation number there for all those are -3, but that's only down to arsenic, not antimony and not bismuth. Those are semimetals that react differently. Okay, oxygen group. I've got 6, easier to gain 2. So if I gain 2, it's -2, but again, that's only down to tellurium. All right, halogens. Halogens are easy. 7, I want to gain 1, so that's -1, and that goes all the way down. All right, now there are 3 other ones where you consistently have. That's silver, +1, zinc, +2, aluminum, +3. Basically stepping stones. So +1, +2, +3. All right, so let's try this. We said aluminum was +3. Oxygen is -2. Now we can either one of 2 ways. What's the common multiple of 3 and 2? The common multiple of 3 and 2 is 6. So if I get +6, I have to have -6. So what number to multiply 3 by to get 6? 2. What to multiply 2 by to get 6? 3. So it's Al2O3. The other way we can do this is swap them down. See this little 3 here? I'm going to zip that over there. See this little 2 here? Zip that over there. As long as it's not a multiple, we're good to go. Let's try another one here. From the periodic chart, remember silver, zinc, aluminum +1, +2, +3. Zinc's +2. Fluorine is a halogen. Remember that column is all -1. Does that equal 0? No. So we're going to write them down next to each other and swap them. So we get ZnF2. All right. So I want you to stop the video now, pause. I want you to do the first 3 for Lewis stop, second 2 oxidation numbers. Pause it means pause it and do them. All right, here's the answers. So there we go. Hopefully that wasn't too bad. Take care. Be good.